The slope of a line describes the direction and steepness of a line. A line increasing from left to right has a positive slope. A line decreasing from left to right has a negative slope. The slope of a vertical line is infinity and is termed as not defined. A horizontal line has a slope of 0. The method of finding the slope of a line depends on what information is available. If given the angle made by the line with the positive sense of the x-axis, then the formula m equals tan theta can be used. The tan function of the angle made will give the slope value. If given 2 points on the line, then we can substitute the coordinates into this slope formula. We start by labelling the coordinates as x1, y1 and x2, y2. These values are then substituted into the formula as labelled. If we are given the line drawn on a Cartesian plane, then the formula rise over run can be used. We start by drawing a right-angled triangle with the line as the hypotenuse. The vertical side of the triangle is the rise and the horizontal side is the run. The side lengths can be read directly from the axis and substituted into the equation. If we are given the equation of the line in the form ax plus by plus c, then we can use the slope formula minus a over b, where a is the coefficient of x and b is the coefficient of y. If the line equation is in the form y equals mx plus c, then the slope is the coefficient of the x term, provided that the coefficient of y is 1. Parallel lines have the same slope, so if we know the slope of a line and we want to find the slope of a parallel line, then m1 equals m2. The slopes of perpendicular lines are negative reciprocals of each other. If we know the slope of a line and want the perpendicular slope, we invert the slope and change the sign. We must sometimes show or prove that two lines are either parallel or perpendicular. Two lines are parallel if their slopes are equal. And two lines can be proved to be perpendicular if we multiply their slopes and the result is -1. We will be practicing all these methods later. The slope of a line is the tan function of the angle it makes with the positive sense of the x-axis. In a right-angled triangle, the tan function of an angle is the ratio of opposite over adjacent. In our triangle, the opposite side is the rise and the adjacent side is the run. As these sides are horizontal and vertical lines, the lengths can be read directly from the axis. The length of the rise of the triangle is the difference in the y-coordinates, and the length of the run is the difference in the x-coordinates. This gives us the formula for slope, where the slope is equal to y2 minus y1 over x2 minus x1. In our first practice question, we must find the slope of the line as shown on the graph. As we have angles, we can use the formula tan theta. Theta must be the angle made by the line with the positive sense of the x-axis. A straight angle is 180 degrees. Subtracting 135 from 180 gives us the value of theta, the required angle. Finding the tan function of 45 using a calculator gives us a slope value of 1. In this question, we need to find the slope of the line that passes through the points A and B. As we are given the coordinates of A and B, we can use this slope formula. We start by labelling our coordinates x1, y1 and x2, y2. We can substitute them directly into the formula as labelled. Simplifying gives us a slope of 4/3. Here we must find the slope of the line shown on the graph. As we have the graph, we can use the slope formula rise over run. We start by constructing a right-angled triangle with the line as the hypotenuse. The vertical side is the rise and the horizontal side is the run. The lengths of these sides can be read directly from the axis. The rise is 4 minus 1 and the run is 5 minus 2. Substituting all this into the formula gives us a value of 3/3. Simplifying gives us a slope of 1. As the line is increasing from left to right, the slope is positive. Again, in this question, we must find the slope of the line from the graph. We can use the slope formula rise over run. So we start by constructing a right-angled triangle with the line as the hypotenuse. The vertical side is the rise and the horizontal side is the run, and both these lengths can be read directly from the axis. So the rise is 4 minus 1 and the run is 5 minus 2. Substituting into the formula gives us a value of 3/3, and simplifying gives us a slope of 1. But in this case, the line is decreasing from left to right, so the slope is negative. In this question, we must find the slope of the line whose equation we are given. As we are given the equation in the form of ax plus by plus c, we can use the slope formula minus a over b, where a is the coefficient of x. In this equation, that is 2. And b is the coefficient of y, which in this equation is minus 3. Substituting these into the formula gives us minus 2 over minus 3. Simplifying gives us a slope of 2/3. In this question, we must find the slope of the line whose equation we are given. As we are given the equation in the form y equals mx plus c, therefore we know that the slope of the line is the coefficient of x if the coefficient of y is 1. In this case, the coefficient of y is 3, so we need to change that first. As this is an equation, we can divide each term by 3. This changes the coefficient of y to 1. We now know that the slope of the line is the coefficient of the x. Therefore, the slope of the line is 2/3. In this question, we must find the slope of a line, but we are told that it is parallel to the given line. We start by finding the slope of the given line. As this is in the form ax plus by plus c, we can use the formula minus a over b. Substituting the coefficient of x and the coefficient of y, we get a result of minus 2/3. To simplify, we take the negative sign outside of the fraction. We know that parallel lines have the same slope, so the slope of our line is minus 2/3 also. Here we must find the slope of a line, but we are told that it is perpendicular to the given line. We start by finding the slope of the given line. As this is in the form y equals mx plus c, we know that the slope is the coefficient of x, as the coefficient of y is 1. We know that the slope of perpendicular lines are negative reciprocals of each other. So to find the perpendicular slope, we invert our slope and change its sign. So the slope of our line is minus 1 over 2. In our last question, we must show that the two given lines are perpendicular. We start by finding the slope of each line. As each line is in the format ax plus by plus c, we can use the slope formula minus a over b, where a is the coefficient of x and b is the coefficient of y. The slope of the first line is minus 2 over 3, and the slope of the second line is 3 over 2. To show that two lines are perpendicular, we must multiply their slopes, and if we get a result of minus 1, that proves they are perpendicular. So, minus 2 over 3 multiplied by 3 over 2 yields a result of minus 1. Therefore, the lines have been shown to be perpendicular. We are now ready to practice on past exam questions. Please do pause the video when the questions appear and attempt the question. When ready, play the video to see the solution fully worked and explained. In this question, we are told that the line P makes equal intercepts on the axis at the point A and B, as shown on the graph, and we need to find the slope of P. As we have the graph, we can use the slope formula rise over run. In the right-angled triangle, made with the x and y axis, with the line P as the hypotenuse, we know that the rise is the length from the origin to the point B, and that the run is the length from the point A to the origin. We were told in the question that the line makes equal intercepts on the axis, which means that the length of AO is equal to the length of OB, where O is the origin point, 0, 0. When we divide these lengths, we get a result of 1. Therefore, the slope of line P is 1. Here we are given the points P, Q and R, and are told they are the vertices of a triangle. We are told that the point U is the midpoint of the line segment PQ, and that the point V is the midpoint of the line segment PR. We are asked to show, using slopes, that UV is parallel to QR. As we are given the coordinates of all points, we can use the slope formula y2 minus y1 over x2 minus x1. We start by finding the slope of UV, so we label the points x1, y1, x2, y2, and substitute them directly into the formula as labelled. This results in a slope of 1 over 5. Next, we will find the slope of QR, so we will label the points as x1, y1, x2, y2. Substituting directly into the formula as labelled, we get a slope of 1 over 5. We are asked to show that these two lines are parallel. As we know that parallel lines have the same slope, therefore UV is parallel to QR. We are given a diagram showing the lines PQ and QR. We are also given the coordinates of the points P, Q and R. We are asked to find the slope of PQ. As we are given all the coordinates, we can use this slope formula. We start by labelling the points P and Q as x1, y1, x2, y2. We substitute these directly into the formula as labelled, and simplifying gives us a slope of 3/4. In this question, we are given the coordinates of A, B and C, and we are told they are the vertices of the triangle shown in the diagram. The point D is the midpoint of the line segment AB, and the point E is the midpoint of the line segment AC. We are asked to show that DE is parallel to BC. As we are given all the coordinates, we can use this slope formula. We start by finding the slope of DE. We label the coordinates as x1, y1 and x2, y2. Substituting into the formula and simplifying gives us a slope of DE as -1/6. We now must find the slope of BC. We again label the coordinates as x1, y1 and x2, y2. We substitute into the formula as labelled. Again simplifying gives us a slope of -1/6. We know that parallel lines have equal slopes. Therefore, DE is parallel to BC. Here we are given a diagram with parts of the lines AC and BC. We are asked to find the slope of AC and investigate if AC is perpendicular to BC. We are also asked to justify our answer. As we have the graphs of the lines, we will use the slope formula rise over run. We start by finding the slope of AC. In the right angle triangle formed by the x-axis and y-axis, with AC as the hypotenuse, we can see that the rise is 3 and the run is 2. This gives us a slope of 3/2. We now will find the slope of BC. Again, we can see there is a right angle triangle formed by the x-axis, y-axis, with BC as the hypotenuse. The rise of the triangle is 3 and the run is 5. We see that the line BC is decreasing from left to right, so the slope of this line is -3/5. The slopes of perpendicular lines are negative reciprocals of each other. To prove that lines are perpendicular, we must multiply our slopes, and if we get a result of -1, this proves they are perpendicular. Multiplying our two obtained slopes gives us a result of -9/10, which is not equal to -1. Therefore, AC is not perpendicular to BC. In this question, we are given the coordinates of the points A and B. We are asked to find the slope of the line AB. As we are given the coordinates, we will use the slope formula. Labelling the points A and B as x1, y1 and x2, y2, we can substitute them directly into the formula. Simplifying gives us a value of 6/-3. Further simplification gives us a slope of -2. Here we are given a coordinate diagram with 4 lines plotted. The slopes of the lines are given to us, and we are asked to identify which line, A, B, C or D, matches each slope value. Looking at the slope values, we see there are 2 positive slopes, 1 negative slope, and also a slope of 0. We know that a horizontal line has a slope of 0, so we can match this slope with the line B. On the diagram, there is only one line that is decreasing from left to right, which implies a negative slope. Therefore, we can match the negative slope of -1 with the line A. Both lines C and D have positive slopes, as they are both increasing from left to right. But the line D is steeper than line C. Therefore, it will have a slope of higher value. So we can match the slope of 3 with the line D, and finally the slope of a half with the line C.